case of the complexity, because it is quite hard to give you a lot of information in a very short time. So, okay, algebra notation. This is the coefficient, as you might have learned from Jeremy's multiplication. And now x is the unknown term. For example, you have a certain amount of chocolates you want to know, but then you have no idea how many there are. So for example, 3C, C is for chocolate, equals 24. Then one chocolate would be 8, because a way of simplifying equations is dividing both sides by the same number. You can do this with any operation, like literally any. You can add, subtract, multiply, and even take square roots and logarithms, which are more advanced things that I won't tell you about. So equations and plot slopes are basically when you have x equals, for example, 2y, no, y equals 2x, which would mean that for example, x coordinate 1, you would have the y coordinate would be 2. Now this would be a point, 1 point on a plane, and then it becomes continuous and forms a line, kind of like this kind of line. It can also get curvy, but it has to do with exponents, which you'll learn later here, which is basically when you have unknown terms to the powers of higher numbers. For example, you can have x squared plus 2x plus 1, which you can do this thing called factorization, which is basically you pack it into 2 brackets, because those 2 brackets can be expressed as 2 numbers multiplied by each other, and therefore you'll be able to get those 2 brackets times each other equals 0. And you can divide both sides by this one of the brackets to just single out one of the unknown terms. They also have 2 answers if it's the power 2. And something known as the fundamental theorem of algebra is that the amount of answers will be the amount of exponents. And then now matrices are something even more complicated, but this is just now getting to the point where you can't really explain it very quickly. So basically, set of numbers is an array, as you can see, and to add them, you add every number in this square, like 3 plus 4 is 7, 8 plus 0 is 8, etc. And why these are important is because they lead to vector spaces, which is a vector is where it's basically an arrow going from the origin of a plane to another place, and these vectors can get very complicated, and the transformations from, like for example, a function, like when you have an input vector and have an output vector, you cannot predict where each point will go by having 2 things called basis vectors, I hat and j hat, being seeing what the scalars are. Now I'm using a lot of jargon because I need to be concise. Complex numbers and complex plane is you see, remember negative numbers? Now remember squares. You can if you take the square root of negative numbers, you find out you can't with any of these numbers you're used to. But then you get to imaginary numbers, which is actually a horrible name. Everyone actually agrees on it. But basically they're numbers which is from another dimension, quite literally, as you can see. And when you square it, it becomes -1. And as you can see, it follows a pattern, because you see square, and then square, right? So it rotates whenever you take it to another power, which is quite important if you want to take, for example, 2 to the power of I, which is also too complicated to explain. Oh yeah, and also, remember these things. There's this thing called calculus, which studies the derivative, how long an infinitely small thing will have to the difference for an infinitesimal. So it's basically the slope at a certain point. And then there's second derivatives, which will be useful for a Taylor series for approximating certain function. And you probably have no idea what I'm saying. So yeah, I should probably stop now. Okay, so how have we got? So here's the matrices, Taylor series, and stuff in calculus, limits. Yeah. Multivariable calculus, which I haven't studied yet. Divergence theorem on tensors, which is related to vectors, as you can see. Now here's Jeremy's surface stuff down up to here.
Yeah.
And now this is about half an hour of going. Now these things at the bottom are mathematical problems so hard that it has stunned mathematicians for centuries. And now it says Millennium Prize problems here. You probably can't read it from this distance, but it just says that. And one of them, to even get a closer understanding, you'll get $1 million. And by the way, people have actually solved these problems before, and he didn't accept the $1 million.
Alright, so now that you have been utterly destroyed by Joshua, and you have decided you are not going to study, you're not going to go to university because you don't want to understand these math stuff, I think it's time we stop the torture. Bye bye.
Yeah.
Very good.